Good evening guys, this is Sumaiya. Welcome back to my YouTube channel. Today in this video we are going to learn about color light effects, and we are also going to learn how to get this color light effects in the Dialux Evo. Let's get started. To start with, let's understand what are color light effects, why do we need this color light effects, and what are the different applications or where exactly can we use this color light effects. Okay, so firstly, what is color light effects? It's nothing but the use of colored light to create a visual effects and set mode in a space. Now, why color lighting effect in lighting design? Well, with the use of color light effect, you can enhance the ambience, you can highlight the features of your architectural details, or you can create engaging and memorable events. We are going to see more project images to help you understand where we can use this color light effect. Okay, some of the examples here are, the first thing is mood lighting. Now what is mood lighting? Mood lighting, the purpose of the mood lighting is to set a specific ambience in a space. Okay, either you can use it in your hotels, restaurants, your personal spaces, residence, etc. Here they have used different colored lights. One is near the counter and other is at the sitting area, two different colors, but it's creating a nice ambience. So the first way you can use the color light effect is to create the ambience. This is the example of this ambience. You can call it as mood lighting. Next, you can use it in your hospitality projects. Like here, if you see the example of the image, it has more warm, cozy atmosphere. It's more than 2700 Kelvin, right? More of an amber color. So it's creating that nice, cozy feeling. This is actually creating a relaxing mood, right? Next, you can use it in your game rooms. This is other example of game room. So these are basically some of the applications when you can use color light effect to create a mood lighting. Next example what we have is for facade lighting. This I think we lighting designers commonly use it. So for facade lighting, we can use it to, what is the purpose is that we can use it to highlight the specific architectural elements such as columns or arches, or we can accentuate the whole facade. This is the reference image for facade lighting. Beautiful gradients of magenta and green, nicely lit. Next, other example, here we are highlighting the arches again with colored lighting. Nice. Here we are accentuating the columns of the facade, beautifully lit. So these are different examples for facade lighting. Next we have thematic lighting, wherein this one, the purpose of this one is to reflect on a particular theme or the occasion. Like suppose for example, here I have the nice picture of India Gate, beautifully lit up with the tricolor lights, that is saffron, white, green, flag colors of India. Nice. So this way you can use the thematic light effect to illuminate your historical buildings, or you can use it to make, like for example, here I have a image wherein the details in the lighting are accentuated with blue light. This more goes with the blue colored logo theme of that particular company, right? So this way you can even make use of thematic lighting. Same way as this is for blue, here we have it for pink, right? So it becomes the brand identity. So you can highlight that brand identity, and because of the use of colored light, you actually remember the spaces. So these are few examples on where and how you can use the colored lighting effect. I hope this one is clear. Next thing is how actually you can achieve this color lighting effect. Well, there are two ways. First one is you can use RGB lights. Second one is you can use color filters or diffusers. Let's see both the ways, and we are going to see both the ways even in our Dialux. Okay, let's start with RGB lights, option 1. So here in the first option, RGB lights, so RGB, red, green, blue LEDs, these are capable of producing a wide range of colors by mixing these three primary colors. Let's see how we are going to do it. Let me open my project. So here I have a sample facade project, and I have got the ULD files for this floodlight, If you need the ULD file of this one, I will provide in the description link below. So I have used ULD files from the Iguzini. Now I have placed this ULD files near the columns. This tutorial is only to explain the color lighting effect. It's not that this is how we actually position. No, this is not how we actually position. This is just for the tutorial purpose. Okay. So here I have RGBW light, and how am I going to do the settings in the Dialux Evo to get the desired output? Okay. For that, you have to go to the light sense, and when you go to the light sense, here is your luminaire. Okay, so since this is RGBW, you have R, G, B and W 4 gears. Okay, I have placed 2 luminaires. Okay, 2 luminaires, 2 floodlights here. Now we are going to see first option is, generally what you do is you go to the lamps. Okay, change, and either you select red, green or blue. Okay, you can do that, but the efficient way I can say is you can go to the light scenes. Here I have different gears. Suppose if I need the green colored light effect, what I'm going to do is I'm going to keep only the green gear on, that is at 100, and rest all I'm going to make it 0. Okay, let's run the quick calculation. Perfect. So this way you can get the, if you need specific color RGB, you can keep only that light effect on. Suppose you want a different color, not standard RGB, you want completely different color. What you can do is you can mix 2 colors. So what I will do is I will keep the green on, plus I will keep even the blue on. Okay, so that means I'm mixing 2 colors, green and blue. Let's see what is the color now. Run the quick calculation. So here you have a different color. This is not your standard RGB. We have achieved it using the mixing 2 colors, green and blue, and we have got this cyan color, right? So this way you can mix multiple colors at different intensities. Like if it is 100, it is at full intensity. If it is 0, then it is off. So you can mix light with different intensities and check the light output. Let's do one thing. Now both are at highest intensities, 100 and 100. Let's reduce one of the intensities, like maybe red I will keep it 100, green I will make it 0, and blue I will make it 50%. Okay, so this is at different levels. I'm mixing different colored light intensities, and let's check the output now. So now you have purple color light. Okay, so you saw the difference, right? When you need only specific standard color, you can keep only that intensity high, 100. If you want different colors, you can do it by combining 2 or more colors and you can even test it with different intensities of the light. So this is the first way, wherein you are using the RGB method. Now before we step into the second method of color effect filters, I would like to explain you few important terms which are very important for us to understand before we go in detail with the technicalities of color light effects using color filters. The first one is, we know that light travels in wave, and this is electromagnetic wave. And when we say light travels in wave, it is a sine wave like this. Now what is the wavelength? Wavelength is the distance between the 2 adjacent points. So when I say you wavelength of this wave, so either you can calculate from this point, from this to this one. Okay, here. Suppose if you're calculating from here, then it will be from here till here. Okay, so this is your wavelength, the distance between the 2 identical points. Okay, so you have understood light travels in wave and how we measure the wavelength. Next, we know that light is a spectrum. Spectrum is nothing but the band of colors, and visible light spectrum is made up of 7 colors, which are violet, indigo, blue, green, yellow, orange and red. Okay, this is under visible light. And when we say light, visible light spectrum is from 380 to 750 nanometers. The wavelength, we are saying that we have different colors, band of colors here, which together make a visible light. and violet has the wavelength 380 to 450. Indigo has from 450 to 485. Similarly, this value is for blue, this is for green, this is for yellow, orange and red. So that's the reason we say wavelength of the visible light spectrum is from 380 to 750 nanometers. I hope these basic terms are clear, because this is very important for us to understand next terms. Understood what is visible light spectrum, that is this. Now, the light which we use generally in architectural lighting, we have of different CCTs, right? We have ranging the color of light ranging from warm white to cool white, right? From 2700 Kelvin to 6500 Kelvin. That, let us see that with an example. Okay, I have my ring light here. Okay, and this is warm white, we have neutral white, and we have cool white, right? So we have different colors of light here, though we just saw now that visible light is from 350 to 780 nanometers, the wavelength. Then how do we have this different light colors, that is warm, neutral, cool white? Okay, so there's a reason for it. Let us understand that reason. Okay, so when you go to the Dialux and you choose the luminaire and you go to the lamps, go to the colorimetric data, change LED. If you see here 3000 Kelvin, 4000 Kelvin, 5000 Kelvin, 6800 Kelvin, and this graph, this is called as spectral power distribution graph, that is SPD graph. You can call it as SPD graph, or the full form is spectral power distribution graph. Okay, this graph actually shows you the intensity of various wavelength of colors. Like if you see here, we have pure itself, but it is at different intensities. Let us understand that in detail. So I have took the snapshot of SPD graphs of different colors of light: 3000, 4000, 5500 and 6800 Kelvin. Now here if you see this graph, SPD graph, you can see that highest intensities, that is the highest intensities here are for red and yellow wavelength. Okay, and then we have lower intensities for blue wavelength. That is why the color of light is more warmer. Okay, and when you go to the 4000 Kelvin, here you can observe that it has the balanced intensity. Red and orange are here, and if you go straight, here is the blue. So this has much balanced wavelength, hence we call it as neutral white. Then if you go for 5500 Kelvin, here it has higher intensities for blue and less intensities for red and orange. That's the reason you have more cool color tones of the light when you are in 5500 Kelvin. Similarly, if you go higher at the scale at 6800 Kelvin, blue intensities are quite very high compared to your red and yellow, which are very less. Okay, so because of this reason, that is different levels in the intensities, we have different color temperatures of the light. Okay, I hope this concept is clear, you have understood it, because next we are going to see color filters. So our first method was we can use LEDs, RGB light, and we can combine two or more colors with different intensities to get the colored light effect. Simple. Now in color filters, this concept is also simple. Here what we are going to do is, if you have a single colored LED and you want to change the color of that, you can use color filters or diffusers. Okay, it's a very simple concept. First we will see it practically, and then we will do it in the Dialux. Let's see how it is done. So here I have a single source LED here. Okay, and then I have some filters. This one, I'll place this color filter in front of this light source, and you get the colored light effect. Simple concept. The same thing you need to apply in Dialux, but before that, let me change the color filter. This is magenta, this is the other one, this is purple, this is blue, and this is red. Did you observe one thing? That the intensity of the light output, is not same for all the filters. Now see here, observe this thing. This is the light source. I have this color filter. I'll place it in front of you and you can see the light effect. And I have the second light filter. I'll change this. I'll use it here. Did you observe the difference with the light output? This is a bit dimmed, but this is bright. Okay, this is comparatively bright than this one. Observe the difference. This one and this one. Okay, this difference is because of the properties of this color filter. Okay, that is transmittance. Now what is transmittance? How much light this color filter is allowing to pass through it is called as transmittance. So this color, it has higher transmittance. That's why the light effect is more brighter. But if I change it with this one, so this filter has low transmittance value. That is why it is more darker. I hope this concept is clear. Bright and dark. This is because of the different transmittance value. We are going to see the same details in our Dialux. So here I have considered a sample project and I have placed LED strips in the column design here. Okay. Now I need to give the colored lighting effect, but with the help of color filters in the Dialux Evo, because I don't have RGB file, RGB IS or ULD file. Okay. For that, what I can do is I have selected the LED and I'll go to the lamps, go to the colorimetric data. Here it is 3500 Kelvin. If you want to keep it, change it to 4000 or 5000 Kelvin, you can do it too. Okay, next thing is we'll go to the filters, select catalogs, filter catalog, double click. So here you have 4 different types of filters. In this tutorial today we will be focusing only on color effect filter. So remember the example I have shown, that I had the color filter of magenta and then I had the magenta color light output. So let's go and select the similar filter in the Dialux. Here if you observe, it has name and transmittance. Transmittance, I already explained you that only this much amount of the light it is going to allow through it. Okay, that means here 66% of the light itself is going to be allowed, rest it will block it. Okay, now I think this is similar to the one I showed you with the example. The name is 328 and the transmittance value is 24.57. Okay, so double click to select it, apply, minimize. Okay, when you see this SPD graphs in the color filters, you might feel it is complicated, but it is not. It is as simple as the example I showed you, wherein this is my light source, then I have a color filter, and then is the output. Same way, the same data has been kept in the, this is for 3000 Kelvin, the light spectrum, right? Because it has higher red and orange light intensities and lower blue light color intensities. So this is warm light. Then we have the filter. The filter also has the color spectrum, and the higher the intensities, only that light it is going to allow. The one which the intensities which are absent here, it is going to block that light. Okay, and if you see, we have another scale here, that is percentage. Now it is 100% and the transmittance value is 21.9. okay, and this is the result, the colored light effect which I am going to get. This is the SDP graph of that colored light. Now suppose in this percentage, if you decrease the percentage of the filter, you can see the change in the result spectrum. If you make it to 5%, this one is similar to this one. That means I'm not using the filter at all. So do not make any changes in the percentage value, only if you required it. This detail will be given in your data sheet, like how how much light output is getting reduced because of the color filter. So accordingly you can set this value, but here let us not make it any percentage, keep it 100%. Scroll down, apply. Okay, let's do a quick calculation. Perfect. You can see the colored light effect. Nice. So this way you can use the color light effect. Now you can say, Ms. Maya, my colored light effect is different for the one which you have done in the YouTube. For that, the reason could be that the lamp color which you have may be differing. So this one is for 3000 Kelvin. Maybe you're using 4000 Kelvin or 5000 Kelvin. That's the reason the filter color is also changing, a slight variation. Okay, so for that too you can refer your data sheets to get the accurate value. Let's check with another filter. Select all, and I will go to the filter, delete this filter. Instead of this one, let me check for any other filter. Let's go with this blue because it has very less transmittance, that is only 2% of light it is allowing to pass through it. Select, apply, do the calculation. Saw the light effect. The light effect, when it was the previous color, the magenta, the light effect was more brighter because the transmittance value was higher. But here the transmittance value is just 2%. That's the reason it is not that bright. I think this color is nice. Okay, so this is how you can use color filter in Dialux Evo to get your colored light effects. In case you don't have the ULD files, you can use this method to get the colored lighting effect. Now I have a pro tip here. Suppose you're working with the option 1 wherein you have RGBW light and you can vary the light to get the desired color, right? But you don't know how much light intensities you have to use to get your desired light output, right? For that, what you can do is go to the light filters, select delete filter, catalogs, filter catalog. Suppose you need this color. Okay, transmittance is 29.95. Double click, apply. This is different from my standard RGB color, right? We have applied the filter. Let's run the calculation. Okay, so this is the effect. So we have the light spectrum 3000 Kelvin on which I have used this color filter, which is allowing just blue and green light, blue and green wavelength. Okay, and it is blocking the red one. Okay, that means here what I can do is, it is blocking the red one, right? So red I'll keep it to 0, white I will keep it to 0, and I have more intensity of light for green. So let me keep it as 100 itself, and I have little less intensities for blue. If you see the result spectrum, blue has less intensities. So maybe I will keep it as 25, enter. Now see the filter properties I have used. The filter properties I have here from referring this SPD graph. I'm giving the same value in our method 1, option 1, by using this is LEDs. I'm controlling the different color of lights. For that I'm referring this filter. Okay, this is just for understanding as a pro tip. Let's run the calculation. Perfect. So if we check our results, both are same. So this one is with our option 1 wherein we can control the light color by varying the RGB and W light color intensities. Okay, and this is with our method 2 wherein I have used directly color filter and I have got the result. So in case you don't have the ULD files to get the colored light effect, you can use the filters. And in case you have the filters but you don't know which setting to do, you can refer the color filters catalog. Okay, I hope this is clear. So this is it guys in this video. If you found this video helpful, please do hit a thumbs up, subscribe to my channel and stay tuned to explore more in Dialux with me. Thank you.